So today we're going to continue our discussion into kinematics. Again, it's motion. We're studying motion. Speed and velocity not the same. And we learned from the last video that speed is the change in distance over the change in time. And it's independent of direction. That is the big difference. Velocity has a direction. So, velocity includes speed and direction. Speed is a scalar. Because this has a direction with it, this is a vector. A magnitude and a direction. So let's talk about Timmy the turtle. Timmy the turtle is going to go for a little walk. And he wanders around to this point in space. He traveled 15 centimeters distance, but ended up 5 centimeters to the east, or 0 degrees, using polar coordinates, 0 degrees. And he did all that walking in 5 minutes. Timmy is not too fast. If we wanted to calculate speed, the speed would be just the change in distance over the change in time. 15 divided by 5. Or his speed is 3 centimeters per minute. His velocity is just his displacement, which was 5 centimeters at 0 degrees, divided by 5 minutes. He only has a velocity of 1 centimeter per minute to the east, along this line. Speed is along here, velocity is along there. And our formula to indicate vectors is simply an arrow over. So the velocity formula is very similar to the speed formula. The velocity equals the displacement over the change in time. And this should go on your formula for your formula sheet for use. Let's try an example. I want to get my speed and velocity from point A to point B on this 400 meter track where B is halfway around. And you notice I give you dimensions, the track's 100 meters wide. Now I'm telling you the full lap took 100 seconds. If I want to find speed and velocity of this situation, first I'm going to make an assumption here that half a lap is half the distance and half the time. Probably a pretty good assumption. Speed is change in distance over change in time. Half the distance is 200 meters of the loop. Half the time was 50 seconds. Divide those and I have 4 meters per second is my speed. At point B, my displacement, and again the formula for velocity is displacement divided by time. Displacement is how far away from the starting point you are to where you are. And if I move 100 meters per second, or I moved 100 meters from A to B, and it's due south, since I made the top of the board north. My displacement is 100 meters to the south over 50 seconds. So my velocity is 2 meters per second to the south. Now again, you can tell that sometimes velocity has a real good number and sometimes speed has a real good number. If you're running this as a race, the speed is a much better indication of what's really happening. If you're trying to get somewhere like Timmy in the last problem, velocity is a much better indicator of what's happening. What happens if I try to go, instead of from A to B, what if I want to do the speed and velocity for one lap? Well, again, I told you it was 400 meters for the speed at 100 seconds. Well, that's still 4 meters per second since we split it in half. But what's my position after I run one full lap back to point A? My position, displacement, how far have I gone? I've moved 0 meters. I started at one point, went around the loop, came back to the same point. So 0 divided by 100 seconds. My velocity in that case is 0 meters per second. So when I tell you in the morning I went for a jog, I always give you my speed, not my velocity, because I come back to the same starting point. My velocity on a morning jog from my doorstep is 0. I start at my doorstep, I end at my doorstep. Displacement is a good key for like how fast Timmy's moving. Speed is a good key when we're talking about races and whatnot. We're going to take this into instantaneous velocity going forward, and we're going to talk quite a bit about graphs.